Okay, Internet Protocol version 4. We have two versions, and the recent one which we are using is IPv6. But still, IPv4 is a very important topic. It is an inter-networking protocol. Okay, and in the coming video, I have explained detail about IPv4. So this is the frame of IPv4. Our next topic is IPv4. It is a internet networking protocol. It is also called as Internet Protocol version 4. Now latest we use Internet Protocol version 6. But still Internet Protocol version 4 is an important topic. It is a protocol of a network layer. Okay? And your some characteristics of IPv4 is it is connectionless. It means if you want to send some data from source to destination, it doesn't form a connection or a route beforehand. Okay, as soon as the process starts, it just selects the best route and it will go. The packets will go. That is connectionless. Okay, and next is datagram service. Datagram service means the entire data is fragmented into packets and each packets will go on its own route. Okay, there is no specific route. The first is the version. Okay, version is 4 bits. This is IPv4 version. So the 4 bits will be 0100. Okay, it is fixed. 0100. 0100 it's number 4 in decimal. Okay, so a version is fixed 4 bits 0100. Next is HEL, that is nothing but header length. Okay, header length is 4 bits, that is 2 power 4. Okay, 2 power 4, and your header length is of 20 bytes minimum, and it can be up to 60 bytes. Your next is your service type, which is of 8 bits. Next is your service type. Service type is also called as DSCP, that is differential services code point. Initially it was like this. Okay, initially it was known as differential service code point, and here in this 8 bits, first 3 bits was known for precedence. Okay, it is your priority, the priority given to that particular data. Okay, D stands for delay, throughput, reliability and cost. If all these data are 1, if this all these segments are 1, it means we care about these things. Okay, if delay is 1, it means we need less delay. If T is 1, it means we need a high throughput. If R is 1, it means it should be reliable, and if C is 1, it means it should be cost effective. Okay, and this stands for reserved bit. Okay, this is 0, it was initially reserved. Okay, now this has been changed like this. The DSCP first 6 bits you have this DSCP, and remaining 2 bits you have for ECN. ECN means explicit congestion notification. Okay, if any data is having any congestion or it is causing any congestion, a notification will be given. So for that this segment is used. Next is your total length. Total length is of 16 bits. Okay, 2 power 16. Next, the second row is for fragmentation. Okay, the purpose of fragmentation. In that first segment is datagram identification. As said before, it will be fragmented and it will be sent part by part in different route. So the receiver has to identify and put them all in place. Okay, so for that this identification is used. Next, your flag. Your flag has 3 bits. First it is reserved, second it is DF, and third it is MF. DF stands for do not fragment. If DF is 1, it means there is no need to fragment, it has been already fragmented. Okay, and MF stands for more fragment. It means there are more fragments to follow after this particular data. Okay, and next is your fragment offset. Fragment offset means how many fragments have been sent before this data. Okay, for example, if our data is if our packet is 5th packet, it means 4 packet has been sent before. That is our fragment offset. So next is time to live. Time to live is if any packet is in a loop. Okay, if it gets lost or if it takes lot of time to reach the destination, we have to drop that packet. So that is your time to live. Okay, so we are giving a time for that packet. If it reaches before that, it's fine, otherwise we will drop that packet. Next is protocol, the protocol of your upper layers. It may be TCP or UDP protocol. Which protocol it is using, that protocol will be mentioned here. Next is for error correction, you have checksum of 16 bits. Okay, next you have source address and destination address. Then you have something called as options and padding. Okay, here only options is given, but you have something called as options and or options for the root. Okay, so in that you have two types of options available. One is record root and one is source root. Okay, in record root, what we do is your packet goes through various routers, right, various routers, and it will record the path for each router, or it will store the IP address. It will store the information of that router. Okay, assume that from A to B it is going, and in between there are two routers. So what it will do is, while going here, it will record the IP address of this. It will record the IP address of this. So each router it will be recording. Okay, so that is your record root. Next is source root. Here source root will have some conditions. Okay, for example, you have here one path, you have here one path, you have here, you have R1, here you have R2. Okay, and here you have R3. Your source root, if it is a strict routing, what it will say is the path followed by A should be R1, R3 and B. This should be the path. Okay, if the source is telling strictly the path, it is called as strict routing. If it is a loose routing, it means your source will just tell that the packet has to reach from A to B. Okay, or it may say that it has to go through R3. Okay, so it has to go through R3, so it can go through R1 or R4 also. Okay, so that is your loose routing. In source routing, there are two types. Strict means it will correctly tell what is the route to follow. Loose means it will just say that it's enough if it goes from A to B through any route, or if it tells any one routing, it